We'll proceed in parameterization of surface in calculus. Parameterization has parameterization in calculus. It has two arena. Parameterization in calculus, it has double arena. One facilitate, you can say leverage, one facilitate method of substitution when we calculate the integration. So if I have to calculate integration of a square root of 1 minus a square minus x square, if I have to calculate the integration of or x into a square root of a square minus x square dx, if these are the scenario, then method of substitution comes into the picture. Consider x equal to a cos theta. Consider x equal to a cos theta. If that is the case, then x outside is a cos theta, and inside this a square minus x square, then it becomes a would come out and it will become sine theta. So a square cos theta sine theta. Now dx would become a minus sine theta d theta. So a to the power 3 cos theta sine square theta d theta minus, this is at least manageable, integration of sine square theta cos square theta. So if someone would calculate integration of sine square theta cos theta, then integration by part, then it would lead in sine square theta sine to the power 3 theta, and then integration differentiation of sine square theta to sine theta cos theta, and then sine theta. So sine square theta to sine square theta cos theta minus outside again. So it is integration of sine square theta cos theta equal to sine to the power 3 theta minus 2 minus integration of 2 sine square theta integration of sine square theta cos theta. So minus 2, I can take left side and it becomes 3 into integration of sine square theta cos theta equal to sine to the power 3 by theta. So net integration is sine to the power 3 theta by 3. At least it is manageable. What manageable? We calculate. So sine to the power 3 by 3. Otherwise, x into a square root of 1 minus x square, a square minus x square is difficult. Someone can try other way also. 1 by minus 1 by 3 a square minus x square to the power 3 by 2 also is workable. Substitution is not required. But whatever, a square root of 1 minus a square root of a square minus x square. Now you tell me how someone can calculate the square root of a square minus x square. That is something that is almost impossible by integration. Now if I take again x equal to x cos theta, then it would result in a sine theta, and there a minus sine theta d theta. So minus a square sine square theta d theta. Integration of sine square theta is known, that is theta by 2 minus sine 2 theta by 4. So minus, if I take it to account, then it will be a square outside, a square, and then in braces sine 2 theta by 4 minus theta by 2, whatever is the limit. So simple, right? The square root of a square minus x square dx, someone would start sweating. Okay, so substitution makes sense. Substitution, method of substitution makes sense. But no, unknowingly, people, they don't know that we are going to different world at all. If a square root of a square minus x square dx is the integration, then it is fx. Fx function over x is the square root of a square minus x square. If y equal to a square root of a square minus x square, then x square plus y square equal to a square. Unknowingly, this is a formula of a circle. X square plus y square equal to a square. If it is a circle, then we can take the use of polar coordinates. The polar coordinate system works in more native fashion as far as circle is concerned, where variation is not seen in x and y, their variation is seen in r and theta. So that's why I made x equal to a cos theta. That is exact equation mapping of polar to Cartesian coordinate system. So if I have a problem in integration and if I do use integration by substitution, then what arena we can take? We can take whatever is suitable to me and it will solve the problem. So when I use method of substitution in integration, and then I can have another variable on which x is dependent, y is dependent upon x, but rather than calculating integration directly over x, now I can make x dependent upon another independent variable, something like theta or t or something that the new independent variable is maps into another coordinate system. So if I say x equal to a function over t, a function over theta, or function over r comma theta, whatever it is, then we are trying to map Cartesian coordinate to another coordinate system. Cartesian coordinate is x and y, where another coordinate right now it is r and theta, that is polar coordinate system. Now work in polar coordinate system and get it back to the Cartesian coordinate system. And your work would be easy. Okay, so that is the kind of scenario. I believe it's all right. Okay, so like if I am trying to do integration of a square root of a square minus x square and then dx and then integration over minus a to a, then square root of a square minus x square where x equal to a cos theta, then a would come out and it becomes a sine theta. A cos theta dx equal to a minus sine theta d theta. Then it becomes now, okay, so it becomes now minus a square and then sine square theta, sine square theta d theta. That is nothing but theta by 2 minus sine 2 theta by 4. Minus a to a is the x limit. Now there are two ways. Since my life is easy when I tried in the polar coordinate system, that is minus a square, and then I have the net integration is theta by 2 minus sine 2 theta by 4, and limit minus a to a is in x. Now bring back that theta by 2 minus sine 2 theta by 4 into Cartesian back. So x equal to a cos theta. So theta equal to cos inverse of x by a. So theta by 2 will become cos theta by 2 will become cos inverse of x by a by 2 minus sine 2 theta, sine of 2 theta, where theta will be cos inverse of x by a and by 4. Now minus a to a. So a, if I substitute cos inverse, theta is cos inverse x by a. When x is a, then cos inverse of 1. Then cos inverse of 1 is 0. Now that side sine 2 theta, where theta is cos inverse of x by a, then it will be again 0. So sine 0 is 0. Full term gone. Okay. So minus a to a. So a is gone. Okay. So cos inverse, now minus a. Now cos inverse x by a. Cos inverse minus 1. Then it is pi. So pi by 2 minus sine 2 theta. So sine 2 pi. gone, pi by 2. So it is now pi a square by 2. Okay, that is nothing but the semicircle area. Now full area is pi a square. This is how nicely I use the kind of polar coordinate system, or someone would try in polar coordinate system completely. Then it is minus a square in braces theta by 2 minus sine 2 theta by 4, and minus a, this limit I can change. So minus a to a, x equal to cos a cos theta. If x is minus a, then theta is pi. And when x is a, then theta is 0. So pi to 0, same result would come, pi by 2 a square. So the scenario is that integration works in two fashion. Either you go by integration by part. Please watch our video integration by part, where we have done many invention also. So how it can be integration by part, why integration by part is the way you see, and it is derived from chain rule in it is derived from the kind of multiplication product rule in differentiation. Differentiation of u and v is u dv plus v du. From there only the integration by part is derived. Another is substitution. This is what we saw. But people, they don't understand, when you are using substitution, you are entering into different coordinate system at all. Like here, I did not think that if I am saying x equal to a cos theta, I am entering into polar coordinate system. So either then you do computation in polar coordinate system, get the integration, come back into the Cartesian, or Cartesian limit also you change in polar and finalize it. So this is so nice, very good. Now someone say, okay, I understood the concept of what is parameterization. Parameterization is nothing but when we change the coordinate system, then it maps through a function. If xy plane maps to r theta plane, then there is a function which relates these two coordinate systems. That function is called parameterization. So like x equal to function over r and theta, this providing x through function function over r and theta. So if you think about any programming function, Python function, then any function f, x equal to f in braces r comma theta. So if f is a Python function, then typically it will be like a signature of a function where r and theta is parameter. This is parameterization. Parameterization in the sense that you are migrating to other coordinate system from one coordinate system, and they are related to each other through the function parameterization. So the new coordinate become a parameter in a function that maps these two. So parameterization. So this is the concept of parameterization. But this is limited to the method of substitution when we calculate integration. So you can say I am so powerful in Cartesian coordinate integration that I don't need your polar coordinate, cylindrical coordinate, a spherical coordinate system. Coordinate. Very nice. If you are so powerful in Cartesian coordinate system, then calculate the curve length of a circle. What is the parameter of a circle? Now you tell me, what is the parameter of a circle? Okay, hands up. Because if I have the equation of the line curve of a circle, this is x-axis, this is y-axis. This is x-axis, this is y-axis. And if I have a curve, then equation of curve is fx, where x-axis is independent component, y component, y axis is dependent upon x axis through a function. Parameterization equals say y equal to fx, function over x. Now if I integrate fx along x axis, it gives me area underneath it. Okay, if this is x axis, this is y axis, and this is kept at x axis. If this is x axis and it is kept at x axis, this is fx. If I calculate integration of fx along x axis, whatever the whole I am showing you, whatever the whole we are seeing, that whole area, underneath area it will calculate, not the curve. What is integration? Integration is, if you have velocity, it will calculate the length. If you have acceleration, it would calculate the velocity. What is differentiation? If you have length, it will give you velocity. If you have velocity, it will give you acceleration. So if I want curve length, then I need to have velocity. Then only integrating would give me the curve length. If I go with the curve length and calculate the integration, it will give the net area. That is the scenario. So if I have y equal to fx, then dy by dx is the velocity equation. Then consider for the circle y equal to square root of a square minus x square, dy by dx would give the minus x divided by square root of a square minus x square. If that is true, then integrating it again would give the length, because that is the velocity. Now try integrating minus x divided by square root of a square minus x square. You would get back the square root of a square minus x square back. That is not the length of the curve. Okay. Sorry, I should have done nothing good. Okay. So it is kind of that we can do more in it. So the parameterization, as we talk always, parameterization is something that eases, it make our integration easy. That is the parameterization. If I have a sphere, and if I go ahead and calculate the volume of a sphere, surface area of a sphere through the Cartesian coordinate system, it would be difficult, because the nature of the item is sphere. Spherical coordinate system would work more. If I have a cylinder, doing the all mathematical computation through Cartesian coordinate would be difficult. If it is a circle, then doing all computation through Cartesian could be difficult. Transform from Cartesian to cylindrical, spherical or polar, then do the computation, it will be easy. Get it back. That is the science. Okay, can I use this science in bigger arena? Can I calculate the parameter of a circle? If I want parameter of a circle, then it is certainly I have to calculate the velocity vector, and then velocity vector, get the magnitude of the velocity vector and then integrate. That is the correct way. So if I have a circle that is centered at the origin, and consider this is the point here, that is x comma y, what is the position vector? If it is centered at the origin, then position vector is xi plus yj, xi plus yj. Then position vector p equal to xi plus yj. This xi plus yj being a position vector, it would move like this. Position vector would move, okay, keeping one end at the same origin, other end would move like this, where x and y is a kind of variable, it would vary. Then dp by d, position vector equal to xi plus yj. Then dp by dx, position vector changes as per the x. There is only one independent component, that is x axis. If this is p vector, then dp by dx would be tangent to it. Okay, so dp by dx equal to I plus dy by dx j. I plus dy by dx j. They are perpendicular to each other. So p vector and dp by dx would be perpendicular to each other. We can prove it. So p vector is xi plus yj. Y I can resolve y yj, and dp by dx is I plus dy by dxj. Let's do the dot product. Then it would result in x plus y into dy by dx. Then x plus y is the square root of a square minus x square into dy by dx minus x divided by square root of a square minus x square. That is gone. X minus x 0. So they are perpendicular to each other. If I have a position vector like this, then dp by dx would be perpendicular to this position vector. Like this is tangent at every moment. If this is tangent at every moment, that is, if I have velocity vector, then if I integrate it back, I'll get the displacement. That is what we want. The length. Anyway, tangent vector is going along the length, whatever it is. So dp by dx is I plus dy by dx j. Get the magnitude of I plus dy by dx j. Get the magnitude I plus dy by dx j. Then this would result in 1 square plus dy by dx whole square root. So it is 1 by x square by a square minus x square root. That would become a by square root of a square minus x square. This is the magnitude of the dp by dx velocity vector. Okay. Now I can integrate dp by dx with dx and get the curve length, because integration of velocity vector would give the displacement. So integration of a by square root of a square minus x square dx, where x is from minus a to a, x-axis minus a to a. If we are talking about Cartesian coordinate system, then we are talking about the top circle, top semicircle. If that is the case, then the curve of the top, I have displacement vector dp by dx, and magnitude is a by square root of a square minus x square. Then that displacement, that velocity vector, if I do integration with dx, I get the displacement of the top semicircle. So a I can keep outside, and 1 by square root of a square minus x square dx. That is the integral. Now I can use parameterization. Here I can use parameterization. Okay. Now I can calculate like dx, consider changing into polar coordinate system. So dx x equal to a cos theta, then dx equal to a minus sine theta d theta. So dx changes into minus a sine theta d theta. A by square root of a square minus x square root of a square minus x square would come as a sine theta. So a by a gone, minus a sine theta remained. So minus a I can keep outside, and integration of sine theta d theta. That is again minus cos theta. So minus I can take out, take inside, it is cos theta. So a cos theta, where theta I don't know, minus a to a is the x. So x equal to a cos theta, x equal to a cos theta. So if I, theta is from where to where, because we are, no, the result is cos theta, right? That is x by a. X equal to a cos theta, then cos theta equal to x by a. Okay, it is x by, we are making some serious mistake. This is what I believe so. We'll try it again. Now the magnitude of dp by dx, dp by dx is I plus dy by dx j. Then it is 1 square plus dy by dx whole square root. 1 square 1 plus dy by dx whole square is x square by a square minus x square. Net is a by square root of a square minus x square, and then integration dx. X equal to a cos theta, dx equal to a minus sin theta d theta. Okay, here a by square root of a square minus x square, a square minus a square cos square theta, a sin theta, a sin theta. Above is a gone, and sin theta gone, minus a came out, and integration of theta. Integration of d theta is theta. So theta minus a and theta, and x limit is minus a to a. So theta is x equal to a cos theta, then theta is cos inverse of x by a. So here theta cos theta equal to x by cos inverse of x by a. If it is minus a, if x equal to minus a, then theta would be cos inverse of minus a by a, that is pi, cos inverse of minus 1. Top is 0, pi to 0, and then theta. So it is minus pi. So minus minus gone, pi a. So the parameter of this circle, top semicircle, is pi a. Net parameter is 2 pi a. Very nice. But how quickly we calculated through polar coordinate system. Okay, so this is kind of fundamental in when we turn the Cartesian coordinate into polar coordinate system and made it happen through polar coordinates. We can take it back. So if I say the integration is minus a and theta, and x limit is minus a to a theta, I can bring in x. I believe we brought x only. So we brought everything in theta, limit in theta. Let limit in minus a to a and bring it back to x. So xy coordinate system, Cartesian and polar coordinate system, do the computation in polar coordinate system, bring it back to x. So theta is cos inverse of x by a, and minus a to a. Same thing will come as pi 1 minus pi. So it will be pi a, and net circumference perimeter of a circle is 2 pi a. So parameterization makes someone life easy. Okay, then how I can change this parameterization as far as vector? Now we see vector is kind of make someone's life easy, right? Easy. So if I have any point on the algebraic path, if I have a graph where it is y equal to fx, y equal to square root of a square minus x square, y equal to square root of a square minus x square, then it is kind of the position vector is is position p equal to xi plus yj. So position vector is xi plus yj. Now, can I represent it using the parameterization? Then x would become function over r theta. If r theta is the polar coordinate and we are changing it to polar coordinate, then f r theta I plus g r theta j, where y is again transformed from the kind of, if y equal to fx, let's change it again. P vector equal to xi plus yj. X equal to g r theta. So g r theta I plus yj. If y equal to fx, then f g r theta. Let's say this would result in h r theta. So g r theta I plus h r theta j is the transformed position vector from Cartesian to another coordinate system. This is if these functions are parameterization, this vector is called parametric vector. Now this parametric vector is represented as r vector. Position vector in Cartesian coordinate, if it is represented through p vector, then new parameterized vector is represented r vector. R on top arrow sign r vector and inside function r comma theta. So vector with function parametric vector equal to g r theta I plus h r theta j. So this is called parametric vector. If I am transforming x only into t, not into rt2, not two dimensional, only one dimension, then here the parametric vector will be function of t1 equal to gti plus htj. Like if I am calculating the integration of square root of a square, integration 1 by square root of a square minus x square, x equal to a cos theta, then a is constant. It is not variable. Theta is only variable. This proves that x is dependent upon only one independent component, that is theta. So the parameterized vector is r vector in parametric theta equal to g theta I plus h theta j. Okay, so g theta I is a cos theta I plus function f over x. F over x. X is a cos theta. What is the function? Y equal to square root of a square minus x square. Then it will become a sine theta. So new parametric vector r vector with parameter as theta equal to a cos theta I plus a sine theta j. Can I calculate the parameter of a circle plainly through parametric vector? Okay, if I try calculating plainly through parametric vector, it's possible. Okay, how it is possible? Now, think that I have a coordinate system. Now we'll take into single dimension. I have a coordinate system that is called theta, and I have coordinate where independent variable is theta, and I have a coordinate system where independent variable is x. Okay, now there is a line in theta plane. If I map this line into x y plane, again there if there is a straight line, then there is a high chance it will be a curved line. If there is a straight line here, it would be a curved line. Now consider this line has a width of d delta theta. So one point is theta. If one point is theta, then another point is theta plus delta theta. Now this side theta point would map as f g, the function g theta. Another point would map as g theta plus delta theta. If I subtract this g theta plus delta theta by minus g theta, then what is remaining here? If I divide it by delta theta, then I can multiply it by delta theta, right? So same thing, right? So if I subtract g is the parameterization function which convert theta plane to x plane, xy plane. Now the 2 point I see in the curve in xy plane is g theta plus delta theta function minus g theta equal to g theta plus delta theta minus g theta divided by delta theta into delta theta. But first term is pure derivative differentiation. Theta